Okay, lots to report on today. I got it fixed, and what I found out was I started by attaching the scope to the any one of these connections here, the red blinking groove. Those are all cathodes. Connect the scope there, and I could see the blinking on just plain raster. You get the normal hash from the snow, then a pulse back down again, and in hash from snow. That's what you expect to see. Well, when I scoped it, I saw that plus on either side it would have snow, a dip, that's a bright line, blanking pulse back down, dip, back up, snow. I had that whenever I clipped right to the cathode of the transistor here, the collector of the transistor here, going to the base, not there. So it was in this collector circuit, so that meant there was something wrong with the collector power supply. I traced that collector power supply through some power resistors to this orange wire. That orange wire comes around to right here. Let's see if I can get my light on it. Where I have this alligator clip. Let me get this light better. Right in there. See that little green cap? Well, that's where the orange wire goes to, right there. That goes to what I thought was a choke, because that's what it shows on the SAMs. It actually is a small diode. Let's take a look at that. Right. You see that little diode indicator? Let's see if you can pick up on the light. That's right. Well, it's hard to see, but that little black thing there, that wire, that's a diode. It's supposed, according to SAMs, it's a choke. And I think in one of the versions, it must be the B plus from the mains uses a choke to help filter it out, and it's probably missing cap right here to supply that collector current to those video outs, but not this one. So for some reason, they just didn't bother to mention that little fact in the SAMs. There's a tiny little filter cap that goes between the oh, by the way, that diode goes back to pin 1 right here of the flyback. So what we have is a flyback pulsed diode to a filter cap to generate boost voltage to run the collectors of those output transistors. Great. Then I look, well, let's take a look at the filter cap. Oh, and by the way, I could see that there was all that, there's a huge horizontal spike coming to that power supply. So I knew there was a problem. Once I started getting narrowed in what was going on, you could put the scope around that orange lead and see it all day long. Not good, because there should be a filter cap, but there's no way it should be happening. So that told me the filter cap was a problem. I've got the filter cap connected up through these. You can see I'm just got a little one stuck in there. And what I found was, okay, this fixes the problem, but it made me I started to wonder, that's boost voltage, that's a 50 volt cap in there. Well, that's because they're taking the positive of the cap to the boost cathode on the diode to where the boost positive is. The negative of the cap is going to the mains B plus, which is normally about 120 volts. This is a little bit higher. I think it's about 130, 140. I'm not exactly sure. I don't recall what it was. So they're looking at, I think the difference in voltage is about 16 volts. That's what I noticed when I actually connected my meter across these 2 points. Okay, so you get 16 volts that you're filtering. So you can get away with a 50 volt cap like they use. But what happens when good old startup cap right here goes south? Remember, this is the one I had to replace because the horizontal oscillator wouldn't kick off. So this cap goes bad, horizontal oscillator does not start. Horizontal oscillator does not start, there's no kickback voltage from the flyback. There's no kickback voltage from the flyback. Ham bone connected negative. Anyway, no kickback voltage from the flyback to be rectified by the rectifier, which was a choke. Anyway, by the rectifier means you've got 0 volts happening on the positive side of that cap, and you've got 130 volts on the negative side. So you got basically the cap is sitting there on 120, whatever the mains B plus is. So you got a 50 volt cap that's now dealing with a potential across its plates, or whatever you call an electrolytic capacitor has, across that foil. 50 volt cap seeing 120 volts. Not good. So this cap fails. Horizontal oscillator doesn't start, which takes out this cap. So anyway, needless to say, what I'm going to do now is I'm going to replace this 50 volt 4.7 UF cap, but I'm going to replace it with a probably I'll find at least 150 volt rated cap, stick it in there. That way, in case this thing ever does decide to go south like this, it won't take out the second cap with it. I guess that should never happen, but I don't know. It just bothers me. You know, what the heck? The caps you have nowadays are small. It'll easily fit in there. So I'll replace that cap, and then I'll have another post one more time with it all fixed. But that was the key, was the boost voltage supply was not being filtered properly. But I didn't even realize that, because when I was looking at the schematic, there was no boost voltage supply. It wasn't even on there, so I didn't know to go looking for it. So there you have it. And I suppose if I'd gone ahead and replaced every single capacitor on this board, I would have eventually gotten to this one and said, wow, I fixed it. I don't like to fix things like that. I like to know what went wrong, and now I have one more little tidbit to file away in the back of my brain when you see that particular thing. Look for the boost voltage if it uses boost, and you know, obviously you need to make sure your filter caps are okay on all your voltage supplies. But I really think that maybe if I hadn't been misdirected looking down the wrong path, I might have gotten this a little more quickly. I like to think so anyway. Anyway, more to come later. Thanks.